The dark universe. Scientists admit 95% of reality is missing. Since the dawn of human curiosity, we've looked up at the night sky and believed we understood what we saw. The stars, the planets, the galaxies, they seem to make up everything that exists. But as our instruments became more powerful and our understanding deeper, something unsettling began to emerge. The universe we thought we knew was only a small fraction of what is truly out there. Scientists discovered that all the matter we can see, everything that emits or reflects light, makes up less than 5% of the cosmos. The rest, a staggering 95%, remains invisible, undetectable, and deeply mysterious. It doesn't shine, it doesn't absorb light, and yet it shapes everything. It bends galaxies, drives cosmic expansion, and determines the fate of the universe itself. They call it the dark universe, a term that describes not only its nature, but our ignorance of it. We know it's there, but we don't know what it is. Dark matter and dark energy, two unseen forces that dominate existence, yet remain untouchable, immeasurable, and perhaps even beyond human comprehension. For decades, scientists have tried to uncover its secrets. They've built machines deep underground, sent satellites into orbit, and created simulations of cosmic evolution. But the answers remain hidden. Every discovery seems to lead to more questions. Every step closer reveals another layer of darkness. In this documentary, we will explore what we know and what we don't about the missing 95% of reality. We will trace the journey from the first astronomical discoveries to the latest theories of hidden dimensions and parallel universes. We will uncover how this invisible cosmos shapes everything we see and why some scientists believe we may never fully understand it. Because the truth is stranger and darker than anyone imagined. This is the story of the dark universe. The cosmic illusion, what we see isn't all there is. It began with a question, a simple one that broke the foundations of modern physics. In the 1930s, astronomer Fritz Zwicky studied galaxies in a distant cluster known as the Coma Cluster. What he found didn't make sense. The galaxies were moving far too fast to be held together by the gravity of their visible matter. By all known laws of physics, they should have flown apart. But they didn't. Something unseen was keeping them bound. Zwicky called it dunkle materie, dark matter. He didn't know what it was, only that it must exist. His colleagues dismissed it at the time, calling it a mathematical mistake. But decades later, other astronomers began to see the same pattern. The more they measured the movements of stars and galaxies, the clearer it became. Visible matter was only a small part of the total mass. The rest was invisible. It wasn't light, it wasn't gas, it wasn't dust. It was something else entirely, a form of matter that didn't emit, reflect, or absorb light. It was everywhere, silently shaping the cosmos. The realization was shocking. For centuries, humans had believed that seeing was understanding, that what we could observe defined reality. But now, the universe itself was telling us otherwise. The visible world, it turned out, was only a fraction of the truth. When scientists mapped the movement of galaxies, they found that dark matter formed an invisible framework, a cosmic skeleton upon which everything else was built. Without it, galaxies would never have formed. Stars wouldn't have gathered. Life would never have existed. And yet, we've never seen a single particle of it. We only know it's there because of what it does. It bends light from distant galaxies. It holds clusters of stars in place. It whispers through the universe in the language of gravity. This was the first great illusion of the cosmos, the realization that what we see is not all that exists. The universe, beautiful and vast, was hiding something deeper. As telescopes improved, the mystery grew. Astronomers using space observatories like Hubble and Chandra began to observe galaxies colliding and merging. In these collisions, the stars and gas behaved one way, but the gravity behaved another. The gravitational pull came not from the visible matter, but from something unseen. It was as if the universe was wrapped in an invisible fabric, and everything we see, stars, planets, galaxies, are just small ripples moving across it. The more we looked, the more this pattern repeated. Everywhere, in every direction, the invisible outweighed the visible. The numbers became impossible to ignore. Only 1 out of 20 parts of the universe was made of atoms, the same atoms that make up everything we touch, breathe, and see. 95% was missing. To scientists, this wasn't just a discovery, it was a humbling revelation. It forced them to rethink everything they thought they knew about physics, space, and time. If most of the universe is invisible, what else have we missed? And if our instruments can't detect it, how can we ever hope to understand it? The universe was no longer a place of light and stars. It had become a shadow realm, one where most of reality hides in darkness, silent but powerful, unseen yet undeniable. The illusion had been shattered. What we thought was everything was only the beginning. The hidden web, the invisible structure of reality. The universe we see, the glowing stars, the swirling galaxies, the clouds of cosmic dust, might appear scattered and chaotic. But hidden beneath that chaos lies a pattern so vast and intricate that it redefines our understanding of existence itself. Astronomers call it the cosmic web, a colossal structure made not of visible matter, but the unseen substance known as dark matter. It stretches across the universe like an invisible skeleton, shaping the positions of galaxies and determining how the cosmos evolves. The first clues of this hidden web came from computer simulations. In the late 20th century, astrophysicists began feeding data about galaxies, gravity, and cosmic expansion into supercomputers, trying to recreate the large-scale structure of the universe. What emerged from those virtual experiments was astonishing. Instead of random chaos, the simulated universe formed long filaments and vast voids, threads of dark matter connecting clusters of galaxies, and immense empty spaces separating them. It looked like a cosmic spider's web stretching for billions of light years in every direction. And when scientists compared the simulations to real astronomical surveys, they found the same pattern in the sky. The universe wasn't a random scattering of galaxies. It was an organized structure with invisible forces guiding its shape. At the heart of that structure is dark matter. Though we cannot see it, its gravitational pull draws ordinary matter into its filaments, like dust collecting along the threads of a spider's silk. Where those threads cross, galaxies form. Where the web is thin, space remains empty and silent. In this way, dark matter determines everything we see, every star that burns, every planet that orbits, every galaxy that spins. All of it is arranged by an invisible architecture older than time itself. It's an elegant paradox. The most important force in shaping the visible universe comes from something we cannot detect. The beauty we observe in the night sky, the constellations, the nebulae, the galaxies, is only the surface decoration of a hidden design. Even now, astronomers continue to map this invisible structure. Using powerful telescopes, they observe how light bends as it travels through space, a phenomenon called gravitational lensing. Light from distant galaxies is warped and stretched by dark matter's gravity, revealing its presence like an unseen hand distorting the fabric of space-time. What they found confirms the simulations. The universe is indeed woven from darkness. Galaxies are not scattered at random. They flow along invisible rivers of gravity, drawn together by dark matter's silent pull. And yet, no one knows what dark matter truly is. It doesn't emit radiation. It doesn't interact with light or heat. It doesn't collide with atoms the way ordinary particles do. It passes through everything, even through us, without leaving a trace. Every second, trillions of dark matter particles may be passing through your body, through the walls, through the earth itself. And yet, you feel nothing. You see nothing. You know nothing. We live surrounded by a hidden ocean, moving through it every moment, blind to its waves. Some scientists have begun to wonder if dark matter is more than just a new type of particle. Perhaps it's a property of space itself, a shadow energy, a side effect of dimensions beyond our reach. Others think it could be the fingerprint of something ancient, left behind from the first moments after the Big Bang. But the truth remains elusive. The cosmic web is real, its effects undeniable, but its cause is still a mystery. It's as if the universe is a vast machine and we can only see the outer gears turning, while the real mechanism remains hidden beneath the surface. Every telescope, every experiment, every theory draws us closer, yet the answers always slip just out of reach. The cosmic web reminds us that the universe is not empty. It is filled with invisible forces sculpting everything we see. It reminds us that our reality is not defined by what we observe, but by what we cannot. In the grand scale of the cosmos, we are like insects crawling across the strands of a web, unaware of the vast pattern we are part of, a structure so immense that it stretches across billions of light years, binding galaxies together in the silent grip of the unseen. The deeper we look into this web, the more humbling it becomes, for it shows that everything, from the largest galaxy to the smallest particle, is connected by the dark threads of an invisible universe. And as we trace those threads further, we uncover something even more mysterious. Not only is there dark matter holding the universe together, there's also something else, something that pushes it apart. It is the most powerful and least understood force ever discovered. The scientists call it dark energy. Dark energy, the force tearing the universe apart. For centuries, scientists believed the universe was a delicate balance between gravity and motion. Galaxies, stars, and planets were all held together by the silent pull of gravity, a force that binds matter across space and time. But at the end of the 20th century, something extraordinary shattered that understanding. In 1998, two independent teams of astronomers were studying distant exploding stars known as Type I supernovae, cosmic beacons that act as reliable markers of distance. They expected to confirm that the universe's expansion, caused by the Big Bang, was gradually slowing down under the pull of gravity. Instead, they found the opposite. The universe wasn't slowing down. It was speeding up. Galaxies were drifting away from each other faster than ever before, as if some invisible force was pushing them apart. A repulsive energy woven into the fabric of space itself. This discovery changed everything. To explain it, scientists introduced a new concept: dark energy, an unknown form of energy that fills the universe and drives its accelerated expansion. It doesn't clump like matter. It doesn't attract. It repels. It pushes galaxies away, stretching the universe larger with every passing second. Today, dark energy is believed to make up almost 70% of all the energy in the cosmos. In other words, most of what exists is something we cannot see, measure, or even comprehend. No one knows what dark energy truly is. Some think it's a property of empty space, a built-in pressure that comes from the very geometry of the universe. Others believe it could be a new field, like a cosmic wind blowing between galaxies. Some even suggest it's a sign that our understanding of gravity itself is incomplete, that Einstein's theory, though brilliant, may not tell the whole story. Whatever it is, dark energy is the most dominant force in existence. It shapes the destiny of the cosmos. If the push continues, galaxies will drift farther apart until the night sky goes dark. Billions of years from now, future civilizations may look up and see nothing beyond their own galaxy. No stars, no clusters, no evidence of the universe beyond. The cosmos will fade into isolation, each galaxy a lonely island adrift in an expanding void. And if the expansion keeps accelerating, it could lead to an even darker fate. Some theories predict a big rip, a future where dark energy grows so strong that it tears everything apart. Galaxies, stars, planets, atoms, even space and time themselves could be pulled apart by the relentless force of cosmic expansion. Others think the expansion may one day slow, reverse, and collapse in a big crunch, only to explode again in a new Big Bang, an eternal cycle of creation and destruction. The truth is, No one knows how it will end. What we do know is this: the universe is not static, not stable, not still. It is alive, in motion, growing faster and faster every moment. And the force driving that motion is something we can't see, can't touch, and can't fully describe. It is a silent pressure everywhere and nowhere at once, a presence woven into the void. When we look into the deep universe, we are not just seeing stars and galaxies. We are witnessing the tension between two great powers, gravity pulling everything together and dark energy pushing it all apart. It is a cosmic struggle that defines the past, present, and future of reality. Some scientists have called dark energy the breath of the universe, the expansion of space itself. Others see it as proof that the universe is stranger than we could ever imagine, a reminder that even after centuries of discovery, we have barely scratched the surface of understanding. Dark energy has no scent, no sound, no color, yet it fills every corner of existence. It passes through us, through the earth, through every atom and every star. It is the silent architect of the cosmos, rewriting the laws of nature with each passing second. And perhaps the most haunting part of all, it has always been there. We simply never noticed. While we were busy studying stars and galaxies, the real story of the universe was unfolding in the darkness between them. Dark matter holds everything together. Dark energy tears everything apart. And we, the humans, the observers, the thinkers, exist in a fragile balance between the two. For all our progress, all our technology, and all our knowledge, we still stand in a universe dominated by forces we cannot explain. We call them dark, not because they are evil or sinister, but because they are unknown. They are the shadows of existence, reminders that for all we have discovered, the vast majority of reality remains hidden beyond our sight. The universe is expanding into that mystery, growing colder, emptier, and darker with every heartbeat of cosmic time. And as it expands, it leaves us with a single, haunting question. If most of reality is invisible, what does that say about us and the small corner of the universe we call home? The 5% we know, our small corner of reality. For all the brilliance of modern science, for all the discoveries that have shaped our understanding of the cosmos, we must face a humbling truth. Everything humanity has ever known, studied, or touched, all the stars, planets, moons, and galaxies, adds up to only 5% of what truly exists. That small fraction is called ordinary matter. It's the matter made of atoms, protons, neutrons, and electrons, the familiar building blocks of everything we see. The screen you're watching, the air you breathe, the blood in your veins, the burning core of the sun, all of it belongs to this tiny slice of existence. The rest, the vast, invisible 95%, is made of dark matter and dark energy, forces we can only sense through their influence. This realization is both empowering and devastating. It tells us that our entire reality, everything that defines our experience of existence, is a microscopic island floating in a vast, unseen ocean. It means that the universe we observe through our telescopes and measure with our instruments is only the visible surface of something infinitely greater. We are cosmic beings made from cosmic dust, and yet we exist inside a reality that is mostly hidden. The irony is profound. The things we take for granted, sunlight, gravity, the ground beneath our feet, are rare forms of matter in the grand scheme of the cosmos. Our world, our solar system, even our Milky Way galaxy, are exceptions, not the rule. When we look at the night sky and see stars scattered across the blackness, we are seeing only the brightest sparks in an overwhelmingly dark void. And beyond that void lies even deeper darkness, the kind we cannot see at all. This 5%, however, is what makes life possible. It is the matter that forms atoms, the atoms that form molecules, and the molecules that form everything from stars to human consciousness. In a way, we are the universe observing itself. The atoms in our bodies were born in ancient stars that exploded billions of years ago. The iron in our blood, the calcium in our bones, the oxygen in our lungs, all were forged in the cores of dying suns. We are made of stardust, literal fragments of cosmic history, condensed in a form, given life, and capable of asking where we came from. But if we make up only 5% of the universe, what does that say about our significance? Are we a cosmic accident? A temporary arrangement of matter that briefly becomes aware before fading back into the void? Or is there something meaningful about this small corner of light, surrounded by the great darkness? Some scientists believe that this imbalance, this tiny fraction of visible matter, might hold the key to understanding why we exist at all. When the universe was born, matter and antimatter should have destroyed each other completely. But for reasons still unknown, a small amount of matter survived, just enough to form stars, planets, and life. Without that imperfection, the universe would be empty. So, in a way, our existence depends on a cosmic flaw, a small miscalculation in the balance between creation and destruction. That tiny difference, less than a fraction of a percent, gave birth to everything we know. The 5% we see is precious because it represents the only part of reality we can touch, explore, and understand. It is the realm of light, chemistry, and life. The place where matter and energy dance in harmony long enough to create thought, memory, and meaning. But as our knowledge expands, the contrast between what we know and what we don't becomes more striking. We can describe the behavior of atoms, yet we cannot explain why they exist in a universe dominated by invisible forces. We can measure gravity, yet we don't know where it comes from. We can send probes to the edge of our solar system, yet we are surrounded by a vastness that defies comprehension. The 5% we understand is a fragile flame flickering in a sea of darkness. It is enough to light our way, but not enough to reveal what lies beyond. And perhaps that's what makes humanity unique. We are creatures of the known, living in the unknown, aware of our limitations, yet still reaching beyond them. Every telescope we build, every equation we write, every experiment we conduct is a step taken into the dark. Because even though we make up only a small corner of the cosmos, that small corner has given birth to curiosity, the one force that refuses to be contained. It is the light that questions the darkness, the spark that seeks to understand the unseen. We may be only 5% of reality, but it is through us that the universe has found a voice, a way to ask its own questions and wonder about its own nature. And so, even as we face the immensity of what we don't know, we remain connected to it. The dark universe surrounds us, shapes us, and perhaps, in ways we cannot yet grasp, includes us. The 5% is not separate from the 95. It is part of it. It is born from it. It is the visible face of an invisible whole. The more we learn about that small portion of reality, the more we are drawn back to the mystery of the rest, to the silent, unseen foundation that holds it all together. And it is here, at the edge of what we know, that scientists continue their search, descending deep beneath the Earth in pursuit of the invisible particles that could reveal the truth of the missing universe. Their journey begins in darkness, literal and cosmic, and it leads us to the next great mystery, the search for the dark matter hunters. The dark matter hunters, chasing shadows underground. Across the world, deep below mountains and beneath layers of rock, scientists are searching for something they cannot see. They're not looking for gold or oil or ancient fossils. They are searching for the invisible substance that makes up most of the matter in the universe. They are looking for dark matter, the silent framework of reality. In laboratories buried beneath the Earth, shielded from radiation and cosmic rays, the world's most sensitive instruments are waiting for a single sign, a faint collision, a whisper of interaction between dark matter and ordinary atoms. These are the dark matter hunters, physicists, engineers, and dreamers united by one purpose: to find the missing 27% of the universe. The search is unlike any other in the history of science. For decades, researchers have been building detectors capable of sensing the smallest imaginable signals. They work in silence, in rooms colder than space itself, hoping that once, just once, a dark matter particle will strike an atom and reveal its presence. The leading theory suggests that dark matter might be made of particles called WIMPs, weakly interacting massive particles. These hypothetical particles don't emit light, don't absorb radiation, and barely interact with normal matter. But their mass could explain why galaxies hold together and why the universe behaves the way it does. To find them, scientists have built extraordinary machines. In South Dakota, beneath an old gold mine, the LUX Zeppelin experiment uses a tank of liquid xenon, a rare, noble gas, cooled to near absolute zero. If a dark matter particle collides with a xenon atom, it should create a faint flash of light and a ripple of electric charge. In Italy, beneath a mountain in Gran Sasso, another experiment listens for the same kind of whisper, a collision so rare it might happen once a year or once in a lifetime. Other detectors lie in Canada, Japan, and China, deep underground, silent, patient, each one waiting for a moment that might never come. Years have passed, decades even, yet so far, no experiment has conclusively detected a dark matter particle. The data remains stubbornly empty. Every failed attempt is a reminder of the enormity of the mystery. Perhaps we're searching for the wrong thing. Perhaps dark matter is not made of WIMPs at all. Some scientists now suspect it could be something more exotic. Axions, sterile neutrinos, or even primordial black holes left over from the birth of the universe. Others believe dark matter might not be a particle at all, but a new property of space-time itself, a hidden aspect of gravity that we have yet to understand. Still, the search continues. In the dark laboratories, the detectors hum quietly, and the scientists check their screens day after day, year after year. For them, the silence is not discouraging. It's a sign that they are pushing the limits of what is possible. They are probing the edge of human understanding. When we look at them, we see the same spirit that drove early explorers across oceans and deserts, the same relentless curiosity that built telescopes and reached for the stars. The dark matter hunters are explorers too, but their ocean is the unseen. Their compass is theory, and their map is written in gravity. Every test, every measurement brings us closer to knowing whether dark matter is real, and if it is, what form it takes. And yet, the possibility remains that we may never find it. Not because it doesn't exist, but because it may lie beyond the reach of our tools and senses. What if dark matter doesn't interact with ordinary matter in any way we can measure? What if it belongs to another layer of reality, one that overlaps with ours but never truly touches it? That idea leads to even deeper questions. Some physicists have begun to wonder if dark matter could be the evidence of parallel universes, invisible realms of matter and energy existing side by side with our own. In these hidden dimensions, gravity may leak between universes, shaping the motion of galaxies in ours. Dark matter, then, might not be matter at all, but the gravitational shadow of another world. It sounds like science fiction, but it is a serious hypothesis in modern physics. The equations allow for it. The observations demand something like it. Still, the dark matter hunters continue their work. They know that every great discovery in science begins in darkness, with a question, a doubt, and a search for proof. For them, the darkness is not an obstacle. It is the field of exploration. They are listening for the faintest whisper of the cosmos, the moment when the unseen touches the seen. Because if they succeed, it will not just solve one of the greatest mysteries in physics. It will change everything we know about existence. It will prove that we were right to believe in the invisible, that the universe, in all its vastness, is far stranger, richer, and deeper than we ever imagined. But until that day, the detectors remain silent. The scientists continue to wait, and the dark universe keeps its secrets. For every discovery we make, it seems the cosmos reminds us, the more we uncover, the less we truly know. The hunt for dark matter is not just a search for particles. It is a search for meaning, a search for where we belong in the unseen architecture of the universe. And as one mystery leads to another, The next question rises from the shadows. If the universe we see is built on what we cannot, could there be even more entire realities hidden beyond our dimension? That question takes us to the next chapter. Theories of the hidden universe. Theories of the hidden universe, parallel realities and dimensions. For centuries, humanity has stared into the night sky and wondered what lies beyond. But now, scientists are beginning to ask a different question. What lies beside us, hidden, invisible, existing at the same time and place, but beyond our perception? The search for dark matter has forced us to consider that most of reality is missing. But if 95% of the universe is unseen, where or what is it? Some of the boldest minds in physics have proposed a radical idea that the missing part of reality might not just be invisible matter or energy. It might be other universes layered on top of our own. It sounds impossible, the kind of concept once confined to science fiction. But mathematics, the very language of the cosmos, has opened the door to this possibility. One of the first clues came from a theory known as string theory. It suggests that everything in the universe, from atoms to galaxies, is made of tiny vibrating strings of energy. These strings don't just vibrate in 3 dimensions, but in 10 or even 11. If true, then most of reality could exist in dimensions we can't access, folded and hidden, like pages of a book we cannot open. In these extra dimensions, entire universes might exist, each one with its own laws of physics, its own version of time, and maybe even its own versions of us. Physicists call this the multiverse hypothesis. One version, called the bubble universe theory, imagines our universe as one bubble in an endless cosmic foam, each bubble expanding in its own space, each containing a separate reality. Our universe may be just one of billions, born in an eternal cycle of creation. Another version, called the many-worlds interpretation, comes from quantum physics. It suggests that every possible outcome of every event, every choice, every moment, actually happens, but in separate, parallel worlds. In one universe, you are listening to this documentary. In another, you turn it off. In another still, you never existed at all. To some, it sounds like philosophy. To others, it's a necessary explanation for the strange behavior of quantum mechanics. The part of physics where particles seem to exist in 2 places at once, where observation itself can change reality. But what if these parallel worlds are not entirely separate? What if gravity, the most mysterious of all forces, can travel between them? Some cosmologists now suggest that dark matter might be the gravitational fingerprint of these hidden dimensions. If another universe overlaps with ours, the pull of its mass could affect galaxies in our universe, explaining why we see extra gravity where no visible matter exists. It means that when we map the cosmos, we might not be seeing missing matter. We might be seeing the shadow of another universe, a parallel world invisible to us, but still shaping ours. This idea isn't limited to theory. Some of the most advanced telescopes, like the James Webb Space Telescope, are now searching for signs of these interactions. Anomalies in cosmic radiation, unexplained distortions in space-time, or signals that defy our current understanding of physics. In 2020, a group of researchers in Antarctica detected what appeared to be particles traveling backward in time, a phenomenon that led some to speculate about a mirror universe, a cosmos running in reverse, where time flows backward and matter behaves oppositely to ours. The evidence remains debated, but the implications are staggering. If confirmed, it would mean that reality has symmetry far deeper than we ever imagined. Our universe might not be alone. It might be one half of a cosmic reflection. And yet, the question lingers. If parallel worlds exist, why can't we see them? The answer may lie in the limits of our perception. We evolved to sense only a narrow band of reality, a fraction of the electromagnetic spectrum, a sliver of what truly exists. To us, the hidden dimensions are as invisible as radio waves were to ancient humans. But they are there, shaping reality quietly, beyond the reach of our senses. The philosopher might say, the universe is not what it seems. The physicist might answer, the universe is more than we can measure. Both will be right. And still, beyond all the equations and theories, one question persists. If there are other realities, can they ever touch ours? Can matter, energy, or even consciousness cross the boundary between dimensions? Some scientists believe it's theoretically possible, through black holes, through quantum entanglement, or perhaps through regions of space where the laws of physics briefly overlap. Others warn that such contact might be catastrophic. Two universes colliding could destroy both, their energies annihilating each other in an instant. But there is another perspective, a quieter one. Maybe the parallel worlds don't exist somewhere else. Maybe they exist within us, in the quantum fabric of our own consciousness. If reality itself is a kind of simulation, if the universe is built from information rather than matter, then every possible world could already exist in the data of the cosmos. The multiverse might not be a collection of separate places, but one vast, interconnected system of possibility. Each thought, each choice, each act of observation might open another branch of reality, spreading endlessly like ripples in a cosmic sea. The hidden universe remains unproven, but its implications change everything. It challenges the idea of a single, objective reality. It blurs the boundary between science and philosophy, and it reminds us that the more we learn, the stranger the truth becomes. If parallel worlds are real, then our universe, our entire existence, may be just one note in an infinite symphony of creation. And as scientists continue to search for answers, a deeper mystery emerges. If reality is layered, then what lies beneath the layers? What is the ultimate foundation of everything that exists? That question leads us into the next chapter, the quantum veil, where reality breaks down. The conscious cosmos, when a universe becomes self-aware. At the end of all our searching, we arrive at a strange realization. The universe is not silent. It speaks, not in words, but in patterns, in symmetry, in the quiet logic that shapes existence itself. And as science reaches deeper into the unseen, one question rises from the darkness. What if the universe is not only matter and energy, but mind? Every atom in your body was once part of star. The iron in your blood, the calcium in your bones, the carbon that builds your cells, all were forged in ancient stellar furnaces billions of years ago. When you think, when you dream, when you wonder, the universe is, in a very real way, thinking through you. You are a fragment of its awareness, a spark of consciousness within a vast cosmic organism. The idea is not new. Ancient philosophers once said that the cosmos is alive, that every part of it participates in a universal mind. But now, modern science is beginning to circle back to the same possibility through the lens of physics and information theory. Some physicists believe that consciousness might not emerge from the brain, but that it is a fundamental property of the universe, like space, time, and gravity. This is known as panpsychism, the idea that every particle, every field carries a faint glimmer of experience. Not thought as we know it, but awareness, the potential to perceive and respond. If true, then the universe is not a cold void. It is alive with perception, from the smallest quark to the largest galaxy. Quantum physics has already hinted at a strange connection between observation and existence. When we measure the world, it becomes real. When we look away, it dissolves into probabilities. Perhaps consciousness is not a late arrival in the cosmic story. Perhaps it has been here since the beginning, the thread that weaves reality together. Some theorists go even further. They suggest that the universe itself might be a self-learning system, a vast feedback loop of information and experience. In this view, galaxies are not just clusters of stars. They're neurons in a cosmic brain, each one transmitting data across the fabric of space-time. If that sounds like metaphor, consider this. when scientists map the large-scale structure of a universe. The web of galaxies, dark matter, and cosmic filaments. The pattern is almost identical to the neural network of a human brain. Two vastly different scales. One, a few centimeters wide. The other, billions of light years across. And yet the geometry, the connections, the flow of information, they mirror each other. Coincidence? Or evidence that consciousness and cosmos follow the same design? Everywhere we look, the universe appears to organize itself toward complexity, toward awareness. From atoms to molecules, from cells to minds, matter seems driven to know itself. It is as if the cosmos is awakening, step by step, through us. When a human being looks up at the stars and wonders where they came from, the universe, for a moment, becomes self-aware. It observes itself through living eyes. You are that moment of awareness, a brief flicker of understanding in an infinite sea of mystery. But what does it mean if the universe is conscious? It may mean that what we call reality is not a fixed structure, but a conversation. Between matter and mind, between the seen and unseen. It may mean that the dark universe, the 95% we cannot find, is not just hidden matter or energy, but the unconscious of the cosmos, the vast, dreaming part of existence from which creation emerges. If so, then dark matter and dark energy are not simply missing pieces of physics. They are the deeper levels of the universe's own being. In this light, every discovery, every star, every equation becomes something more than science. It becomes reflection. The cosmos is looking inward, trying to understand itself. Through us, through thought, through curiosity, the universe learns what it is made of. Perhaps that is why we search, not just to survive or to know, but because something within us, something ancient and infinite, is remembering. The scientists call it research. The mystics call it awakening. The truth may be both. The universe may be far darker and stranger than we can comprehend. But within that darkness lies the spark of awareness, the quiet realization that the observer and the observed are one. The cosmos and consciousness are not separate. They are reflections of the same mystery. And maybe, just maybe, the reason 95% of reality is missing is because we have been looking outward when the key to the dark universe lies within. From the birth of stars to the depths of quantum fields, from galaxies to the human mind, the story is the same. An unfolding of awareness, a movement from chaos toward understanding. The universe is not only expanding, it is awakening. The universe is vast beyond imagination. We have measured its age, mapped its galaxies, and captured the light of stars that died billions of years ago. Yet, for all our progress, the truth remains humbling. We still understand less than 5% of what exists. The rest, the 95%, remains invisible, silent, and mysterious. Dark matter, dark energy, the hidden forces that shape everything, yet reveal nothing. It is a reminder that no matter how far we reach, we are still standing at the edge of an endless unknown. Science began as a way to bring light into darkness. But as we've peered deeper into the cosmos, we have discovered that the darkness itself is where the real story lies. What we cannot see, what we cannot measure, may hold the secret to everything. Not just the origin of the universe, but the nature of existence itself. We search the stars for meaning, not realizing that meaning is what gives the stars their light. We build machines to find the hidden matter, not realizing that the most mysterious force of all may be the consciousness that built those machines. Perhaps the dark universe is not a void, but a mirror, reflecting everything we do not yet understand about ourselves. The unseen cosmos and the unseen mind may be two sides of the same coin, each trying to recognize the other across the vast divide of awareness. And so we keep searching, not because we expect to find all the answers, but because the act of searching itself is what makes us human, and perhaps what makes the universe alive. In the end, The dark universe is not our enemy. It is our origin, our destination, and our reflection. Every question we ask, every discovery we make, brings a little more light into the unknown and reveals that even in the deepest darkness, there is structure, there is beauty, there is meaning. The more we learn, the more we realize that the universe was never truly missing. It was waiting for us to notice, because to understand the cosmos is to understand ourselves. And in that moment of awareness, the universe looks back and knows its own name, the dark universe.